Okay, so in section 10.2, what we are doing is 4 more calculations, 4 more different conversions, but the style, the procedure is exactly the same as it is with all dimensional analysis problems. We're just using new conversion factors. That's basically what we learn each day, is another new conversion factor. So what we learned in the very first part of this chapter was going from particles to moles. And then the next thing, and vice versa. And then the next thing that we learned was going from, moles to grams and grams to moles. But we've only practiced that with atoms, I shouldn't say atoms, with elements. So we haven't practiced that with the molar mass of compounds. So that's the first thing that we need to do here. How many moles, so circle the do, are in 258 grams of sulfur hexafluoride? That's why it was so important in chapters 7 and 8 that I really stressed you need to be able to go from a formula of a compound to the name of a compound and vice versa. Because when we write problems like this, we often don't say the formula, we say the name. So you need to know how to go back and forth between the two. So if you see a prefix in there, the prefix tells you how many, it's covalent. Sulfur hexafluoride is SF6. And if we are going from grams, so we have to write 258 grams of SF6 out front. And now I do a conversion. I know that 1 mole of SF6 equals the molar mass of SF6. So in my calculator, I'm doing 1 times the molar mass of sulfur, 32.07, plus 6 times the molar mass of fluorine, which is 19. And the answer to that is 146.07. And you don't need to write this down, but I like to write this down so you can see where I'm getting these numbers from. So the question is asking me to convert to moles, so I know 1 mole is going to go on the top, and 146.07 grams of SF6 goes on the bottom. And then my calculator, 258 times 1 divided by 146.07. And the answer comes out to be 1.76627. And then, of course, I have to look at the problem again for significant figures and units. So remember, the 1 in 1 mole doesn't count for significant figures. 258 has 3. And you may look at that number and say 146.07, that has 5. But remember, I got that number off the periodic table. And so the maximum number of significant figures that it can have is 4. So I'm just going to always count numbers off that I got off the periodic table as 4. I haven't rounded because we don't round in the middle of the problem. So that means my answer should just have 3 significant figures. So I look 1 digit beyond, that tells me I'm going to need to round up. So my answer is going to be 1.77, and then the grams cancel, so the unit that I have left is moles. So 1.77 moles of SF6. Here's 2 more problems for you to try. How many grams would 2.007 moles of baking soda have? So circle the do, grams, underline the clue. 2.007 moles of baking soda. Baking soda is NaHCO3. Right? So 1 mole of baking soda. Sodium hydrogen carbonate, that's the actual chemical name of baking soda. 1 sodium, 1 hydrogen, 1 carbon, 3 oxygen. It comes out to be 83.998 grams. So moles, I know moles is going to have to be my unit on the bottom because those two need to match so that they can cancel out. On the top, 83.998 grams. Right? I put this problem into my calculator. The answer that I get is 168.583. Now look for significant figures. That number has 4. Any number off the periodic table has 4. So I should round this to 168.6. I'm going to round it up. The units of moles cancel, so this would be grams of sodium hydrogen carbonate or baking soda. The next question, how many moles are in 10 grams of copper 2 nitrate? I want you to try and do this problem yourself. The first thing that you're going to need to do is figure out, well, what is the formula for copper 2 nitrate? Remember copper, if they have a Roman numeral 2, that means that the charge is 2 plus. Nitrate is a polyatomic ion with a charge of NO3 minus. So you're going to crisscross the charges, get the formula for copper nitrate, find its molar mass in the periodic table, and convert 10 grams of that to moles. I'm going to give you the answer, 0.05331 moles of copper 2 nitrate. So I want you to try this for yourself, and if you don't get this answer, go back and look and see, what could I have done wrong? Maybe find your molar mass over again. Or maybe, look up, what is the formula for copper 2 nitrate? Did I get that right? What is the molar mass for that? Did I get that right? And make sure that your units cancel out. Because just copying the work that I do isn't necessarily going to teach it to you. You have to try it for yourself. And I have a second problem for you to try for yourself. What mass would 0.067.67 moles of sucrose have? The answer for this is 23.16 grams of C12H22O11. Sucrose is table sugar. So try this one out. See if you get 23.16. So that's the first type of problem today. The second type of problem is really getting at the heart of what we were talking about. This whole chapter is about counting by massing. So if I have 1 mole of water, and I know 1 mole of water would be 6.022 times 10 to the 23rd molecules, but I also have learned that 1 mole of water is 18.016 grams. Think about in geometry, you did this all the time. If two things are equal to the same thing, then they must be equal to each other. So what does that mean? If 1 mole is equal to 6.022 and 1 mole is equal to 18.016, then 6.022 times 10 to the 23rd molecules must have a mass of 18.016 grams. And this will allow us to count by mass. How many molecules of carbon dioxide are in 5.88 grams of carbon dioxide? So I take the number that's given to me and I write it out front. I have to find the molar mass of carbon dioxide. The molar mass of carbon dioxide is 44.01. And now I can do this problem in 2 steps using these 2. Let me change their color. Using these 2 conversion factors, I can do this problem in 2 separate parentheses. But if I notice that they're both equal to 1 mole, so they must be equal to each other, I can actually just do this problem in 1 parenthesis, because 1 mole may be equal to 44.01 grams of carbon dioxide, but it's also equal to 6.022 times 10 to the 23rd molecules of carbon dioxide. And anything that these are 3 conversion factors, they're all equal to each other, so I can put them in parentheses any way that I want. I need to match up the units, so I'm going to put 44.01 grams of carbon dioxide on the bottom, and the question is asking me to convert to molecules of carbon dioxide. So on the top, I'm going to put 6.022 times 10 to the 23rd molecules of CO2. Right, so in my calculator, 5.88 times, I can do alpha M, or put in Avogadro's number, divided by 44.01 grams. I get my answer. It is 8.0457 times 10 to the positive 22. And of course, right, we're always looking for significant figures. 5.88 has 3. 6.022 and the molar mass have 4. So my answer is going to round to 8.05 times 10 to the positive 22. And of course, looking at my units, it's not CO2. The grams units cancel out, right? So this is essentially what we set out to do at the beginning of the chapter. How can I count by massing? So if I need 8.05 times 10 to the positive 22 molecules of carbon dioxide, I now know I should weigh out 5.88 grams of carbon dioxide, and vice versa. The next one, what mass in grams should 5.77 times 10 to the positive 20 formula units of NaCl have? Right? So what mass in grams, and then that is what I start with. 5.77 times 10 to the positive 20 formula units of NaCl. Right? It's asking for grams, so I know at some point I'm going to have to calculate the molar mass. I know that 1 mole of NaCl equals, and on my calculator, I add 1 Na and 1 Cl, and I get 58.44 grams of NaCl. But of course, I know that that's always equal to 6.022 times 10 to the 23rd formula units. So I now match up my units like we always do. So the bottom here is going to be 6.022 times 10 to the 23rd formula units of NaCl, right? So we can't use molecules, but it's sort of the same idea. And on the top, right, whatever I'm converting to needs to go on the top. The question's asking me for mass, so I put 58.44 grams on the top. And then my units, of course, are going to cancel out. I plug this into my calculator, 5.77 times 10 to the positive 20 times 58.44 divided by Avogadro's number, or alpha M, and 3 significant figures is what my answer is going to be. And what is it? 0.0560 grams of NaCl. Okay? And one thing that you should really take notice of is one strategy when solving mathematical problems in chemistry is to kind of estimate your answer. And sometimes that's really hard. But one thing that you can do is, like in this previous problem, it was asking for a number of molecules. Remember, molecules are extremely small. So the number of molecules should be a very large number. And in fact, it will never be less than 1. So the fact that I get a very large number for my answer is probably right. Over here, it's asking for grams. Well, grams can be big or grams can be small, but it's not going to be like times 10 to the positive 22. Like that's like how many grams the earth weighs, like that's ridiculous. So, we can have numbers that are less than 1 in terms of grams. We should never have a negative of any of these, that's for sure. So that's one way to sort of check to see, am I doing this right? Especially if you're not sure. We have 2 more types of conversions to do in this section. So that's going to be our next video, and that will be kind of it for conversions for this chapter.